How's everyone doing? All right. You excited? How many came to the presentation on Wednesday night and saw some of this? Okay. So you're going to see some of the same things again. But I got a new one. Okay. Got a new one. And actually, this one's a particularly hard one. It's running right now. What's specifically happening is I'm streaming sensor data live on the stage from these little guys right here, and we'll play a game with them in a second, to my own Wi-Fi router, which is also sitting here on stage. So this is my router, okay? Streaming it into my laptop, and my laptop is pulling it through Vertx, running right here, in the background. So that's Vertx just running. It's about this amount of code, so we're not talking a large body of code. And then it's streaming it out directly to my browser. That's what's happening here. Now, you guys ready to get started now? Okay. Let's go ahead and get started then. Are you guys going to record this too? Fantastic. Okay. So this is a fun one. Let's see if it works. I'm not currently on the network. I'm on my private network, and there's a reason why. So we're going to talk about reactive programming. We're going to talk about reactive systems. If you saw my presentation on Wednesday night, we'll cover some of those same demonstrations. We can get them all working again, but this is one that is kind of special because it does take a little setup. In the future world, right, where you have mobile devices by the billions, or you have IoT devices by the trillions, you cannot do traditional synchronous enterprise Java programming models and keep up. You will be overwhelmed. Either you'll have to put a fleet of clustered servers out there, like, by the thousands, or you have to do things asynchronously. Otherwise, you simply cannot handle the volume. That's kind of the key point with this particular demonstration. So all I have here right now are two sensors running. Two sensors that I just started about 15 minutes ago, actually. Now, less than that, I think about it. I started the sensors earlier, but I just started the counting a few minutes ago. So within just, let's say, 10 minutes, I have already 3,400 transactions into the system with two sensors. Now, so for instance, I was at the Port Authority yesterday as an example. They intend to automate fully, industrial automation, to basically say, look, when a container needs to move from ship A to ship B, onshore, get this crane, take this container, go from here to here to here, that's going to involve a lot more than two sensors. When you put that level of robotics into a system, you're going to have dozens of sensors, as an example, per machine and per device. And so I'm working with organizations that are working in the industrial Internet of Things, and they literally are going to put out hundreds per area of these kinds of sensors. So that's why having a reactive programming model can really help you in this case. So if you look right here very closely, you can see that I'm receiving two types of sensors. One's called a TI-CC2650, one's a 2541, and they both are, because I turned this thing on at the same time, they both have seen now about 1,700 transactions or actual sensor readings. You can see the temperature coming here in Celsius. They're about the same, but they're not the exact same sensor. Therefore, they have slightly different readings. You have to know about these kinds of tricks when you live in this space, because every sensor from every manufacturer is going to be slightly different. This is actually the same manufacturer, just two different models, and they're slightly different, even though they're sitting side by side. Now, this is where it gets interesting. Just to kind of hopefully make a point here for you guys. This is simply me SSH'd into the devices. So actually, let me have two volunteers. Who can volunteer? I just need two volunteers real quickly. Who wants to? It can be anybody. How about you, ma'am? Would you like to step? It's super easy. And you, sir, come on up here. All right. So here's what this is. You can be on this side, and you can be on this side. All right. So this right here is my Linux server. This is my Linux computer. The biggest thing about this is actually the battery. So it's running on a battery. It has both a Bluetooth radio and a Wi-Fi radio on that. It's known as the Intel Edison. I'm actually working to replace them right now with a Raspberry Pi Zero. The new Raspberry Pi Zero that actually has the Bluetooth and Wi-Fi. I left them in the hotel because they're not quite right yet. Because Wi-Fi is fine, Bluetooth is tricky. I'll let you know that now. And so the device itself is this guy. You can hold on to him. He's the TI sensor tag, and he operates via Bluetooth to that Linux server, who's then communicating via Wi-Fi through this Wi-Fi router, over to my laptop. So watch what happens here. Okay. So if you don't mind, just put your hand over, just kind of enclose it in your hand. Okay. And you can kind of see the temperature changing. We're now up to 40 degrees. Now kind of open it up and let it cool off a little bit. You can open it up, just like that, and you'll see the temperature drop. So here's the top graph right there. So if you would grab that one. Okay, same idea for you. If you cover it up, see it, you just covered it up and it started shooting up in temperature there. So if you kind of open it up, let it cool, you'll see the temperature drop. And if you heat it up, you'll see the temperature, right? You could. You could. You will have to worry about distance. So I actually am working with a specific company that with Bluetooth, you have some limits, right? So all of this is based on radio frequency. It's all based on 2.4 gigahertz technology, right? So you could put it in your pocket. You could wear it. Okay, I actually like your idea there. It will still work, but within a certain distance, and then you'll start seeing failures. Packets will get lost. So you probably could go sit back in your chair without a problem. Okay, but it also has a lot to do with RF interference in the room, or RF interference with industrial machinery. So you would probably be fine in this distance. You could probably be fine all the way in the back of the room, but it depends on how many other devices are between you and that. I know that sounds kind of odd, but this is the kind of things you have to think about. But from a programming model standpoint, you guys can try to, well, look at yours actually went crazy. It's up to 200 degrees now. And these and you can see now it's reset itself. It figured out probably it was an error, and it's come back. But all this is simply happening with these little sensors through these little Linux servers into the Wi-Fi router into the system. So I asked these folks here just because to prove that it works. Okay? Is that fair? Cool? Thank you so much. Thank you. Now her question about how far can I take it is very, very important. Okay? Because let me show you this. Again, in a reactive world, in an async world, you can do this little temperature sensor thing, which is what we're doing right now. And by the way, that sensor actually streams 10 different senses. It has temperature, humidity, a barometer for humidity, as well as air pressure. It also will do a gyroscope. How much is it moving? That's a very important one. Vibration is very important to actually track in an industrial setting. Vibration tells you when a machine is going to break. Right? So heat and vibration are two things you primarily want to monitor. But also you have to look at things like, it has a compass, right? A magnetometer. And also has a luxometer, how much light is in the area. So if you're trying to monitor darkness or lightness for a reason, you can do that too. Now, this distance thing is super important, because here's what you can do with a little Bluetooth device, because we specifically gave Bluetooth chips to a whole bunch of people like yourselves at a conference. They put it on their lanyard. They had a little Bluetooth chip, just like this little guy here, but cheaper. This guy's about $29 with all its sensors. The one with just the Bluetooth beacon on it was $5 each. So we gave several hundred of them away, so that's why they had to be cheaper. But we then set up Raspberry Pis, kind of like my little Intel Edisons, in rooms around the building. And as you entered from room to room to room, it's constantly sending out its beacon, and we're constantly monitoring your activity by basically grabbing that UUID. Every Bluetooth radio has a unique identifier, grabbing that unique identifier, sending it to our Spark engine, Apache Spark, who's doing real-time analytics to say, which sensor are you closest to? And this is what you get when you do that. So this is actually at a Boston Convention Center. We processed over 7 million transactions through the course of a conference day. And you can kind of see everyone in the top right there showing up at breakfast. That's the breakfast room. So everybody's showing up for breakfast. Okay? You can see we're sampling traffic. Now we go to breakouts. All right? So you see us coming to the breakouts right here. These are the breakout sessions. And we go back and forth from breakout to breakout to breakout. And so this is a streaming, I recorded this that same day. And then about 4 o'clock in the afternoon, everyone starts to gather for our keynote. You can see there's a little bit of other activity. You can see watch what happens here, because we specifically have a keynote, and there's everyone going to the keynote room now. And now let me just pause it there, because what we specifically wanted was to say, when everyone showed up at the keynote, we could show them they showed up for the keynote. By the way, each of these was uniquely identifiable. You could click on these balls, and it would tell you who it was. Okay? I did make a joke at that point with everybody say, look, okay, we didn't put any sensors in the bathrooms nor the bars. So all we know is if you were in the break room, right, or in the breakout sessions, that was it. But we then had our session, our keynote, and then everyone left the keynote kind of thing. So you kind of see people ebbing and flowing. And as the day goes on, you start seeing them leave the building. So we're about 10 o'clock at night now, you know, and people are just leaving the building for the day. 7 million transactions processed, all with a bunch of $5 Bluetooth sensors and a series of Raspberry Pis, pushing it through Apache Spark engine and doing real-time analytics to draw this graph. So this graph actually updated in real time all throughout the day. And I asked the team to put in a mechanism so I could capture the data and record it. That's all. So I have this video. So that's an example of a reactive system also. We specifically use Vertx actually as part of the implementation of this. So does this give you good context for what we're about to talk about now? Okay? We already spent 10 minutes on this. We got to get moving faster. So let me do this. I'm going to switch to, I'm just going to switch actually to my phone just to make this simple. All right, there he is. Let me get online here, and we'll get started with this presentation. See, we haven't even started yet. Okay, look, this thing's still running. Yep, okay, all right, let's go over here. Come on, connect. It's trying to connect. There we go. Okay, so a couple things to note. I specifically work for an organization called Red Hat Developers, or developers.redhat.com is our URL. There are stickers that are in the booth. There's also this cool t-shirt in the booth if you will stop by and sign up for the developer program, which is free. If you're there early enough, you get one of these cool t-shirts that I'm wearing now. But Vertx is specifically the technology we're going to talk about at this moment. Okay, so there's a book that's available to you at our website. You can download the book and also get started on this journey, specifically Reactive Microservices, which is the architecture we're going to talk about today. From a developer standpoint, you have to think in these terms. If we were from the 70s, I actually did not program in the 70s, though I might look that old, but maybe you did program in the 70s, and if you did, you only had to know 2 of 3 skills. You had to know COBOL and whatever mainframe you had, and depending on the mainframe, you probably did JCL or WIFL. Actually, I did WIFL for a little while. Workflow language if you're a Unisys Sperry universe, JCL if you come from the IBM universe, and that was what we did in the 70s. In the 80s, it got a little more complicated. So we had to learn things like C++ or C. I did a lot of C programming in the 80s. We learned 4GL technologies. We learned things like CASE, computer-aided software engineering. I was a NetWare administrator for a period of time. That was exciting. You're thinking, what's NetWare? I know, it's old. But we learned relational database technology, SQL, and Unix. And in the 90s, it gets even more complicated. The point of this is we're constantly learning, we're constantly evolving as software engineers, we're constantly growing as developers. So now in the 90s, we learned HTTP and HTML. We may have heard of CGI. We had get, put, post, delete, cookies. I used to have to explain to people, cookies were not going to steal their credit cards in the 90s. I'm serious. I would travel around the globe telling people, software people, they were like, I can't add cookies to my software. It's going to steal people's credit cards. No, it's not going to steal people's credit cards. But we keep going. In the OOs, the early 2000s, right, we introduced things like Strut, Spring, Hibernate. This is when the JBoss app server exploded onto the scene. We didn't have to pay $80,000 for WebLogic any longer, as an example. We learned XML and web, WS Splat, various web services technology. Ajax was born in that decade. We probably picked up something like Subversion in that decade, as an example. And in the 2010s, the decade we're in now, probably HTML5, and that stuff you just saw actually is some HTML5 technology, IoT technology, mobile technology like iOS and Android, maybe some Mongo, NoSQL kind of thing, and Reactive is one of these skills. So my point with all of this is just one more skill. And you already have a ton of skills that you probably have started to at least learn or maybe even master. I can tell you I'm not a master of hardly any of these things. I just know how to dabble in all of them in many cases. But if you do all this, you'll be a Silicon Valley unicorn, right? This is the GitHub unicorn, by the way. But you too can be the mythical beast. So the reactive technology is where we're at for this particular presentation. Reactive programming is often seen as a subset of functional programming. It will show you some reactive programming. It's super simple. But there's 2 real players in that space, RxJava and Project Reactor, that are very popular. RxJava is the most popular at this moment. But RxJava specifically came from the folks at Netflix. They looked at this technology from C#. It came from .NET originally, from Microsoft Research. They figured out this reactive programming model. They put it in C#.NET, and then of course Ben Christensen at Netflix saw that as a good thing and re-implemented it as RxJava. And now we have RxJava, RxJS, and all these other reactive solutions for every language on the planet. So RxJava is primarily the one that I'll focus on here, but reactive programming is actually not that hard. It is different, but it's not that hard, okay? On the other side of the equation, though, you have to think in terms of reactive systems. We'll spend more time here because reactive systems is where it gets interesting. Okay, reactive programming, pretty easy. Reactive systems, actually fairly tough, fairly hard. And this is the world of Akka and Vertx specifically. These are the 2 main players in this reactive system space. You can actually build reactive systems without Akka or Vertx. You could do it all with C++ if you wanted to. It's certainly possible because it's a style. Okay, it's not a specific framework per se. It's a style of how you build your systems. So in this case, you can think of Vertx as a solution for reactive programming or reactive systems. We're going to focus more on the second half of that. The reactive system definition is primarily defined by the Reactive Manifesto. So if you go to reactivemanifesto.org, they're going to talk about being responsive as well as elastic and resilient. Now, the key component of that is message-driven. Everything is async by default, async message-driven technology. You never block a thread. It's the whole idea. There are threads, but you do ignore threads. They don't exist in your world. If you use Akka and the actor model, it's a single-threaded actor. If you use Vertx and our model, it's an event loop. It's still a single thread that you worry about, meaning you don't program any differently than you would in, let's say, a servlet or an EJB or Spring Bean, because there you don't deal with threads either normally either, okay? Now, the number one rule here is be responsive. What do your users do if your website is not that responsive? Anyone have an idea what users do? What do you do when you're like, this site's a little slow? Refresh, refresh, refresh. Because you're helping those guys, right? You're actually giving them yet a whole other transaction they cannot respond to. So you're not helping them by refreshing, 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 though that's what we do as software people and non-software people. And I've noticed here in Singapore, I'm doing this more often. Because there's a higher latency here, it turns out, for servers actually in the US as an example, and I've learned that the hard way. We'll see that hopefully in a few seconds. But being responsive is the ultimate thing. You've got to be responsive. Even if your response is, I'm sorry, I can't help you right now. For instance, let's say you show up at the grocery store or the retail outlet and you're in the mall, wherever it might be, and you see a 5-person queue. There's a long line, a big queue to get checked out at the cash register, to get the item that you need from the checkout counter. If the person at the checkout counter nicely leans around and says, oh, I'm sorry, but I'll be with you in a minute, you will wait 10 more minutes. If they ignore you, you will leave immediately. This is the nature of how humans work. It's the same thing is true of websites also. So being responsive is critical. To make that point, I will show you this demonstration. Okay? Come on, exit out of, look at that beach ball, going crazy. All right, let's shut this guy down actually over here. And let's go over here. We don't need these guys running anymore. Let's see if they'll shut down for me. And actually, I changed networks. They're not going to shut down for me, so fine, just go away. So let's go over here. Let's find the right item. I'm going to show you just a simple little Spring Boot application. Let's go ahead and get it running. And let's a little Spring Boot application. Kind of make the point here. Let's actually look at this little Spring Boot application right here. It is this guy. It is 13 megabytes in size. That's the Spring Boot application running as a fat jar. It's now up and running. If I come over here and actually interact with it, I go to localhost, and it actually says, and we can say goodbye. And actually, let's watch it. So if I hit goodbye, goodbye, goodbye. Works great, but it works with a thread pool. Like all enterprise Java solutions, it works with a thread pool. So if I actually send in too many requests, watch what happens. So there go all our requests, and look what happens here. The browser locks up. All the threads are in use. Every other request is in a queue. You probably didn't know you had a queue for your web server, but they all have queues. And I'm now waiting until a thread becomes available and then can respond to my request. Now it just did. Okay, now I'm back to good again because, well, technically it's still backed up. I think I sent in 200 requests for 100 thread pool. That's what it is. Now this is not doing a thread.sleep. It's actually calculating pi. It's just running a bunch of really horrible business logic that takes a long time. That's all. It's calculating pi and takes about 8 seconds per transaction. So now we're back to good again. Okay, so in the face of overwhelming load, this application was not responsive. It was overwhelmed, it did not respond. And don't think I'm picking on poor Spring here. Here's my app server, okay? So this is Wildfly Swarm. It works basically the same way as Spring Boot, same idea. And it's just that it will also get overwhelmed because it's based on a thread pool. It's kind of the idea. And actually, let's look here. You can see it. So that was a 13 megabyte Spring Boot. This guy right here is, this guy right here is 50 megabytes. So ours is a full, more app server kind of thing. It's bigger, it's 50 megabytes. But that's still pretty small if you think about it. The whole thing, app server and application and 50 megabytes. But let's go over here and, all right, we're good. There we go, it's responding. We put in 200 requests. And let's see, there, all right, it's still responding now. And there we go, we're locked up again. So my user is not being served. So this is a simple concept, but this is actually the architecture we're used to dealing with. This is the world we live in today with our WebLogics and WebSpheres and Tomcats and everything else that we're used to dealing with from an enterprise Java standpoint. Now that we have a thread available, all right, we're good again. And if you hear my CPU fans right now, they're going crazy because all that calculating of pi on those CPUs. And it looks like we finally have processed enough. All right, so let's run Vertx now. Okay, we're going to run Vertx here. And let's see, there we go. Vertx starts a lot faster than the rest of them. And let's also go here, look at the size of that Vertx implementation. And it's this guy right here. And it is 6 megabytes. It's half the size of the Spring Boot application and a tenth of the size of the Wildfly Swarm application. Vastly smaller. And it's also faster starting. Now watch what happens, though. Oh, not that. Let's go here. Get the right button. All right, let's push in a bunch of transactions again. And it keeps working, right? My system is a little bit slower because I actually have a lot of stuff happening from a CPU standpoint, but it always responds to the user. You can even see the responses to my user in the middle of all those long-running transactions. So it's always responsive. There's never a thread being blocked. It's always async by default, and it's based on an event loop. It's actually based on a single-threaded model. So it actually can process more transactions through a single thread than the other guys can through multiple threads. There's a trick to it, obviously. But from a programming perspective, it just works. So if I come back over here, I have this code open. Let me show you this piece of code. Where'd it go? Where'd it go? Well, okay, yeah. Here we go. So this specifically right here is our Spring Boot application, standard at-rest controller. Of course, you have get mapping now, but request mapping, request method get, standard Spring ABC, standard Spring REST controller stuff, right? This is what you always see. Here's the business logic. It prints out the message. It computes pi. It tells you when it's back from, I call it a nap because it seems to take so long, it takes a nap is the idea. So that's what happens there. Here's the Wildfly Swarm version of the same, okay? This is Java EE, JAX-RS. Instead of the at-rest controller, you have at get, at put, at post, delete. Same concept, same business logic. Same, just different annotations. It works the same way. Here's the Vertx version, and it is going to be a little bit different. The Vertx version basically has the same business logic, because it's just Java. But how you set it up is a little bit different. This is how you specify your URLs in a Vertx world, all right? So we'll just kind of zoom in on this a little bit more. It has the concept of the router. A web router allows you to basically say, for this URL, this URL, this URL, and parameters, it could be URL parameters or posted parameters, etc. You basically then map it to a handler, okay? This handler has a context, and in this case, it's basically saying respond. In this case, the end of the response, because by default, responses are chunked. It assumes you're going to stream, but we're not going to stream here. We're going to respond with goodbye. Here's the goodbye message, goodbye on Vertx. And of course, with this URL, it hits this piece of code, this bit of business logic, which calculates pi. So everything else is the same except for these two lines, basically. And the magic is actually this thing called the blocking handler. Because we know that piece of code runs really long, we say it's a blocking component. Because by default, you'll get an error message out of Vertx if you start blocking. If you don't say blocking handler, you'll get errors. Say, hey, you're blocking. Stop. Don't do that. You never block the event loop. You never block in Vertx. If you have to block, you say so, and then you push that off to a background thread pool. There's still a thread pool. You just don't worry about it. Okay? So the foreground event loop is always available to process a user request. So this is seemingly crazy, but if you actually are familiar with Node.js, this looks familiar to you. This is where these ideas come from. Is that cool? Okay? Let's jump back into it again. Let's keep going here. And actually, I got to go faster. Okay, you guys are thinking faster. But here, let's talk about microservices briefly. So that's my intro to reactive programming and reactive systems. Now let's talk about microservices. Not everybody needs to be doing microservices. And I've actually been in meetings all this week with various organizations throughout Singapore, and I can tell you it's actually a good thing to stick with traditional monolithic architecture. Microservices is not for everybody, because you have to be able to pass these kinds of tests by Martin Fowler, as the ThoughtWorks people. You must be this tall, and if you guys aren't familiar with this expression, I'm a little guy. I'm a little guy by US standards. I was actually born in Hawaii. I'm half Japanese, but I grew up in Alabama. And when I'm a little person in Alabama and Georgia, North Carolina, where I live, and I want to ride roller coasters. But I'm too short to ride a lot of roller coasters in the United States. And actually, when I was a kid, I was definitely too short. So they have a sign in front of the roller coaster that says, you must be this tall to ride the ride. And I would walk up to it, and stand on my tiptoes and try to convince the guy to let me on the ride. It worked a few times. Now, you got to be this tall to ride this ride. You got to have self-service, on-demand, elastic infrastructure. If it takes you 3 weeks to get a virtual machine, you aren't ready to ride the ride. If it takes you longer than 3 weeks, I talk to people like 3 weeks, 6 weeks to get a virtual machine. If it takes you longer than that, you really aren't ready to ride the ride. If you can't get a new virtual machine within, let's say, an hour, you're not ready to ride this ride. Resources like that, cheap resources like a virtual machine, think about how much those things cost. Nothing. How much does your time cost? I don't know, $50 an hour, $25 an hour, $100 an hour? You have to wait days or weeks to get a zero cost item? It makes no sense. It actually sends a bad cultural signal to the organization. Expensive resources, wait on cheap resources. Bad move. So that's bullet number 1. How long does it take? Dev versus ops. If you throw it over the wall on Friday, if you as a developer check in your source code on Friday at 4:45, you head out with all your buddies to the bar, you're doing shots of tequila. I know you're not here, but let's say you're doing that. You're having beers, and the operations team is trying to figure out how to make that code compile, tested, deploy it, and all weekend your crappy code is hurting them. You're not ready for microservices either, okay? You will be there all weekend with them. As a matter of fact, you are on the pager now in a microservices world. You are now accountable for the quality of your code and the runtime performance of it and the capabilities of it from a business metric standpoint in production. If you're willing to do that and your organization is willing to do that, you might be ready for microservices. Okay, automation. If you guys know the difference between a Snowflake server and a Phoenix server? Snowflake servers are super cool, right? Someone racked a new 1U rack-mounted server out there. Maybe they even put some VMs on or whatever, right? But they basically threw new servers out there in the data center, and somebody SSHs in and yum install or apt-get install and blah, 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 blah. They tweak some initd scripts or systemd scripts, right? And then they leave it running, and in some cases, they run everything in the background, and they don't normally leave the terminal open because that would shut down some processes. You guys have had this problem before, right? And then they leave it running. And guess what they can't do to that server? They can't reboot it because they have no idea if it reboots, if it'll come back to life correctly. And you may think I'm kidding. I run into people all the time who have this problem. So that's a Snowflake. It's a unique, pristine server that only the person who set it up, who didn't take good notes, by the way, and in one case actually was talking to a company who had this problem. The gentleman who set it up was actually hit by a bus in a massive car accident, actually, and was out for a month. And they did not have any idea as to how to operate their servers. Here's what a Phoenix server looks like. A Phoenix server is a VM or even a piece of hardware. You use something like Puppet, Chef, Ansible, or even something super clever like Kubernetes. You bake out a script, even if it's just a shell script. You bake it out to perfection. You check that into source control. You know exactly what it takes to rebuild that server at a moment's notice. And if there's a bug in the server, you might SSH in to see what the problem was, but you go back to the original script and fix it there. You never fix it on the server itself. So therefore, you can burn the whole thing down and rebuild it in moments. That's the Phoenix server. So you got to be on the Phoenix side of this equation if you want to live in this new microservices world. You got to think in terms of CI/CD, and you got to think in terms of your deployment pipeline. These are all parts of the equation. But let's keep going here. If you have not read these 2 books, you must read these 2 books. Please read these 2 books. The Phoenix Project is a phenomenal book. It's super easy to read. It's not as cool as Game of Thrones, I'll tell you that, okay? But it's close. It's actually a work of fiction, and specifically it's a work of fiction where they are launching a new project within an organization, and they find that when they have a bad deployment, they take the business down for days. This happened to me one time. I had a bad deployment. I took the entire business offline for days. I had the people, the customers, the business people, writing transactions down on paper. Seriously, they went back to paper. The good thing is the guy was old enough, the accountant there, he knew how to do paper still. Some people can't do paper anymore. They would just be stuck. They were taking credit cards by hand. They were doing credits and debits of people's refunds by hand. And we even locked people out of buildings because part of the system actually triggered a door lock for the employees and stuff like that. We locked people out of buildings. That's what the Phoenix Project's kind of about. The DevOps Handbook is the follow-on to that. It's, of course, written by Gene, Jez, Patrick, John. These are all people you should be following on Twitter today. This gives you practical guidance and just user stories and what people have done out there in the ecosystem. Definitely you got to read these books, okay? So in the old Java E world, you had an operating system, you had Java Virtual Machine, an app server, you had an ear, you had wars, you had multiple wars and jars, and this is where it got tricky. Because of this monolithic architecture, you all had to agree. Everyone had to agree. Enterprise architects set the standard. They defined what this was going to look like. They defined what this was going to be based on the ugliest, worst-case workload in your whole organization. You must use WebSphere ND. You cannot move Java use to Java 8. You must live in the past by 3 years. You have to live on this old version of Linux. You can't be on a modern version of Linux. You have to pack up your ears, boards, and jars, in this certain way. Everyone had to agree. And those actually weren't that bad. Well, WebSphere ND is a different issue. But one thing that was super bad is you all had to agree on the same Maven Central dependencies. You know how often we get customer support cases where people have loaded 3 versions of Spring into their app and it doesn't work anymore? Yes, right? So 2 versions of Hibernate, it doesn't work well if you mix and match versions across some of these dependencies. You need to pick the right stack. So getting all those things to agree with a big team of people like you see here, all these developers, operators, etc., it's a challenge. If you have 45 people working on a big monolithic code base like this, you all have to agree, and this is why it goes so slow. This is why you only deploy every 6 months. This is why you only deploy every 9 months. It's a high ceremony release that involves everyone working super hard to pull this off. Now, in the world of microservices, you split it up into smaller independent teams. We refer to these guys now as 2 pizza teams because you can feed them with 2 pizzas. I've been in Singapore long enough. We're not talking Singapore pizzas. We're talking American pizzas because this came from Amazon. So it'd be maybe 4 Singapore pizzas, okay? 4 pizza team. But the whole concept is 6 to 8, maybe 10 people work together. They include all the capabilities they need. If they need an awesome DBA, they got a DBA. They need a business analyst, they have a business analyst. They need Java coders, front-end coders, Node.js coders, they got the coders. They got the operators, and they holistically own that piece of the system all the way into production until end of life. There is no throwing it off to some offshore people who will just babysit this thing. They own it forever. It is their product. They take great pride in ownership. They ensure it's brilliant, as an example. So you build it, you own it. These are the Amazon principles, as an example. So these are the key characteristics of a microservices architecture. Number 1, you have to have deployment independence. If you cannot independently deploy your component without disruption to anyone else, you cannot do microservices. It's really simple. If you have to coordinate deployments across, release schedules across all these different teams, you're not going to go fast. And the whole point of this is to go faster, to get to production faster, to learn faster, to get experimentation done faster. And if you can't go faster, why are you doing this? You're just simply hurting yourself. In my quickie this afternoon or lunchtime, I'll show you demos of these things. We're not going to do the demos now. But the concept of deployment independence is absolutely key. A couple other bullets here you want to keep in mind. You need to have decentralized governance. Now, this is really going to blow people's minds, right? This is where each independent team makes their own decision that's best for them. If they decide Go as the programming language is the right solution for them, they will take advantage of that because that best meets their business needs. They might just do WordPress because that meets their business needs, okay? So they will be independent of each other, and they will also have independent databases. These 2 bullets is what breaks the back of most average enterprise IT shops. They're like, nope, we're not doing that. We have a nice enterprise architecture team, and they dictate all the rules around here. They said WebSphere ND on Java 6 for the next 10 years. And you have to suck it up. And I'm talking to my programmers in the room like, God, those architects, they never let us do anything. And actually, the architects aren't the problem. It's the DBAs, right? DBAs never let us do anything. But that's really what we're talking about here. Architects and DBAs, 6 and 7. They're not going to let you do this, okay? Keep that in mind. So, if you do have a decentralized data management problem, Edson Yanaga is actually here. He wrote the book on this topic, and you need to read this book and understand the principles and techniques in it so you can actually deal with a potential database issue. So, monolithic database problems, go read his book. He'll be signing the book, I think, at 3:30 today in the booth, and he's here giving a presentation on this topic. So, Edson Yanaga, check him out. These are all the different microservices concerns you should be thinking about. I don't want to spend too much time on them because they can actually be fairly hairy, and actually I'll demo a lot of these things to you a little bit later in my second session. But just keep in mind, you need to be thinking in terms of not just your code base, but how do you deal with load balancing and scaling and elasticity, resiliency, discovery, logging, distributed tracing, what is your API strategy going to look like? These are all the things you have to have really researched to do proper microservices. If you're just trying to do microservices with, oh, I'm using Spring Boot, I've got a REST endpoint, let's go run it, you're not going to have fun with that. As a matter of fact, you're not going to go any faster with that. You're probably just going to make a big distributed ball of mud. All right? It's going to be spaghetti at the ultimate level. And it's not going to be fun for anybody a few years down the road. Now, you're probably thinking, I'm going to check out of this organization, leave it to someone else. Keep in mind that whenever we as developers or architects have said, God, what was that person thinking? The person who comes behind you is going to think the same thing, okay? Because you don't know the constraints that they had to work under. You don't know the politics they had to work under and the technical ramifications they had to deal with. You're going to make bad decisions today that'll be future legacy tomorrow. It's just the nature of what we do, okay? So these are things you need to be thinking about, okay? There are some key patterns. Again, I don't want to spend a ton of time on this because we'll do the demos later, but this is common in the retail outlets. They will use the browser to aggregate server-side components. So the browser, mobile browser in this case, will call components on the server side. Very common in the retail outlets that I see. So I use a retail example here. You can see that my top-level description, my price, my star rating, the descriptors here, the thumbnail images. There's 15 available in my local store. All these, in the case of the retail group that I worked with on this, are often mainframe invocations. So they specifically are calling from the mobile browser to a server, an edge service. It was Tomcat at one point, but they ran out of gas on Tomcat. And then they would then in turn call the mainframe. The reason I called this pattern out is because this is really, you really want some async capability. Because the mobile browsers are not diminishing over time. They're only growing over time, and especially here in Asia. The number of people getting smartphones, Androids in particular, like all the folks in Bangalore are trying to get iPhones. I was just there a couple weeks ago. Everybody's getting a smartphone, and they're all going to hit your site, and they're all going to want responsiveness from your site. And if you can do the asynchronous capability here, especially if you have to go to some other resource like a slower mainframe, a slower old school database, a slower old school Java EE application, then it really behooves you to put an async layer here as the API gateway or as the edge service. Some people say, oh, is this where Zool fits? Netflix Zool? Sure. This is what Netflix invented Zool for. This is what Netflix invented RxJava for and Hystrix for. But Vertx fits the same space. All right? This is where Vertx can live as an example. You also have to think in terms of failure. What happens if the mainframe does not respond at all, or worse, more insidiously, does not respond in a certain SLA? I need to respond to my mobile browser within 1 second, let's say, 1 second. Mainframe sometimes takes 2 seconds to respond. I need to be able to short circuit that right there, break that connection off, and you can do this asynchronously. You can't do it synchronously, right? It's only in the async world you can do this. And I'm going to respond to my user in a clever way. We'll see where it says 15 available right now. I'm going to respond with, oh, I don't know if 15 are available, but I still know your store. That's based on the GPS of the device. So you change your user interface, you change the behavior of the application, you change the business logic based on the things you can report back on, not the things you cannot. So this concept, this architectural pattern is incredibly important in a microservice in this next-gen cloud-native architecture. You have to think about these things. This is exactly what Netflixes and Walmarts and Amazons do. If you ever log into Netflix and you'll notice the user interface is different from the day it was before, my wife tells me this all the time. She's like, these aren't my thing. I never even watch these movies. Sure, right? I never watch these shows. And she's right, because Netflix is responding based on overwhelming load with default data. It's not her choices. It's just default data. That's how they deal with it. The same kind of concept here. Okay, let's keep going. There's also the concept of the API gateway where you aggregate that on the server. So again, the nice thing is you catch the error here. There's also the concept of the chain, and you want to make sure you don't have a cascading fail, roll up your chain to the user. These are all things you have to think about in a microservices architecture, okay? And of course, most people will actually they'll basically kind of massage this into their own way of thinking, but these are the things you'll think about, and again, I have some demonstrations of this in our next session. All right, so the circuit breaker is something you'll want to keep in mind. We'll show you a circuit breaker later today. But the idea is that by default, the circuit is closed. That means all transactions are flowing, but you have a monitor in the middle. The monitor is going, are transactions good? Are they responding as we expect them to? Or are things getting slow or actually not responding at all? If it sees things getting slow or not responsive, it opens the circuit, which means things just bounce off now. So basically, if that component is dead, you don't kick the dead guy any longer, you bounce off, and you get an immediate fail. And that way you can respond to your user, your mobile browser, with the default data that you have. And this concept of the circuit breaker was popularized by a project called Hystrix as an example, but we also have circuit breakers built right into Vertx as an example. But you can use Hystrix too if you want. Okay, so I'm going to skip that particular piece of demo because I got much cooler demos to show you. Let's talk about Vertx now. So we talked about Reactive, we talked about microservices, let's talk about Vertx. Vertx is a toolkit for building reactive applications on the JVM. So we could do this with Node.js. This is actually where we learned a lot of these things. This is the Node.js universe. But I want to do it on the JVM. I'm a Java guy. I've been a Java guy for 20 years. Well, I can tolerate JavaScript. I write very bad JavaScript. Mostly because I hate the fact that I don't get compile time error checking until runtime, right? That's just an issue of mine. So this is what you can do from a Vertx standpoint. By default, you'll get the core right here, where you can speak HTTP or HTTP2. HTTP2 stuff is really awesome. We have a deep dive presentation on that, not at this conference, but just keep that in mind. UDP, TCP, you can basically open a socket and let bytes flow. And that's what you might do with this particular technology. That's what we were doing with those IoT sensors. We were just simply opening up port 1883, which is the MQTT port, and letting bytes flow. So from the Bluetooth to the little Intel Edison over Wi-Fi into the laptop, we're just dealing with a stream at that point. So that's something super simple you can do with Vertx, and it took a page of code for that. It took one class. Okay? It doesn't take much to do some of these things. You also have the concept of the eventbus and shared data. So the eventbus, we'll see numerous examples of that, and we'll show you some live demos of that. But it is super nice because you can specifically have all your JVMs linked together on a common shared piece of memory, essentially. They're clustered together in a peer-to-peer network, and they can work with each other and communicate with each other. Therefore, you can defer jobs to other members of the cluster, and you can communicate broadcast messages to the whole cluster. You can even do request-to-reply messaging across the cluster. And then now the question in your mind is, oh, that's a messaging broker. No. It is simply in-memory clustering, right? There's no real message broker here. There's no guaranteed delivery because we're not writing these transactions to disk and ensuring that the subscriber who eventually comes back online gives us the acknowledgement that he did receive that message and then deleting it from disk. That's called a message broker. That's your ActiveMQ, your Apache Kafka, your RabbitMQ. That's what those technologies are. That's not this. This is purely for ultra lightweight messaging to make all these cluster members talk to each other. We can share data with each other. We can share processing with each other. We'll show you an example of the event bus. There's some other aspects of this, like you can build web applications using like time leaf and templating mechanisms. You can, so if you want a standard AngularJS, RESTful backend, React, Angular, that kind of thing, with a nice Vertx backend to that, no problem. That's not a problem at all. You can use different programming languages like Java, Groovy, JavaScript, or Ruby. So I personally like Java, but I have a whole demo based on Groovy as an example, and actually some Ruby and JavaScript in there too. So you can basically mix and match all these components. Your jar file does get bigger depending on which of these you add in. The one I showed you earlier was super small, 6 megabytes. You get a little bigger as you add these guys in because they're just additional jar files you add to your application. But you can see that Vertx can actually build whole applications using the same ideas, right? So just like any other application solution. It's an un-opinionated toolkit for reactive async applications. It makes async easy. That's really the focus of what we've been doing with it. And you have the concept of the Vertx instance. You have these verticals. That's how we refer to them. Think of them as programs. Think of them as classes in Java sense. It'd be a .groovy file, a .rb file, .js file, or .java file, right? That's your vertical. That's what they are. They all have the event bus available to them, even if you stay in the same JVM, right? They can communicate with each other all within the same JVM or across JVMs. And that's really what we're going to see in a moment, okay? It's all based on this concept of the event loop. The event loop is super simple. You have, let's say, browsers giving you get, put, post, and delete, IoT sensors, whatever it might be, flowing in. Those events are coming through a queue. You basically have this while true loop. It's just looping, and it says get the next event, find the registered handler. In the case of the IoT sensor, oh, there's a handler that says I want to handle that IoT sensor's data. And it, in turn, does a dispatch, okay, to an async call to update the browser. So it's async, 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 but it doesn't really look that hard, right? Because the programming model. So this concept of the event loop is just what is the architecture here. This is all single-threaded from your perspective, okay? If you have a multi-core machine, you actually get an event loop per core. So this is important. It's a multi-reactor pattern. Some people refer to it reactor pattern, multi-reactor pattern. The reason this is important is there's actually a lot of benchmarks on the public internet you can Google and find to talk about Vertx versus Node.js. And Vertx often won. And people are like, how is that even possible? Node.js is the fastest thing ever created in history. It's actually not. Okay, if you go to Tech Empower benchmarks and actually look for Node.js in those benchmarks, it's sometimes in the 10th or 12th place. A whole lot of people are beating Node.js these times, Vertx being one of those who's beaten it in a few categories. And one of the reasons Vertx beats it is because of this. We can take advantage of all the cores you give us. Okay? Super simple. But in other cases, it's serialization for this, or it's the optimization of the JVM with the JIT. Things. Everything wins in different ways. But I can tell you that the C# guys, I've met them. They guarantee you they're going to beat Node.js. They're all over it. If they're not number one today, they're going to be number one in the future. Have you seen the Kestrel server that's built in the new C# core? It's amazing. So that's a different thing. But everybody's fighting for that. Here we go. Here's a super simple main method. A super simple application, I mean. So it's my main vertical. It extends abstract vertical. This is typically what you write. So it's one import statement, one class declaration, one method, and in that method you then set up the rest of the things. This sets up the HTTP server, and you can see right here it simply responds with a hello Vertx, and it listens on port 8080. Okay? And if you're familiar with Node.js, you're like, oh, that's kind of like Node.js. Exactly. Okay? And then we also have the getting started part of it. I won't spend a lot of time on this, but you just create a directory, and then you basically can run this if you want to. This actually is just a Maven plugin that will generate a default Vertx application for you. You can copy and paste it from these slides, and then Maven compile Vertx run. And the cool thing about that is it treats Java as a dynamic language also. So Groovy and Ruby are dynamic, but it treats Java as a dynamic language. It'll dynamically compile it on the fly every time you make changes to it and rerun it. And it's just kind of neat. It just hot reloads the Java files on the fly. And this is what maybe a more advanced program might look like. You can see here there's the router, so I specify the specific routes, and then I have very specific business logic to respond to those route requests. So simple RESTful endpoints are very simple, okay? Let's see here. This is the concept of the router. It basically routes to different handlers and actually sends out the responses. Here's what a more advanced router might look like. You can see we actually have, in this case, this is a method reference. We have the parameter right here. You can see where we're going to this delete one. It's basically, these are just other business logic methods associated with these routes. That's all. You also have the concept of a static handler, meaning if you have HTML files, CSS files, JavaScript files, it'll load those too. Moving pretty fast, aren't I? We're not moving nearly fast enough. We're almost out of time, so let's get going. Okay, let's show you these things. Let's see if in fact my stuff is still working here. We'll find out. Let's see, can I get into my server? Come on, connect for me. I'm using my phone here. There we go. All right, so I have a server out on the public internet. It's at web.burr.red. You guys can try it out. But let's do this. And I'm just basically navigating a Maven project, as you can see right here. I have Java. All right, I have com. I'm trying to remember these things. Burr, Reactive Workshop. I did all these for a Reactive Workshop in Sweden not too long ago. And there's my vertical. So VI main vertical. And let's look at it here. This has the router built in. So basically, it has some neat things in it. Like if you actually respond, so if you get the root, it just responds as this little bit of text. If you actually get hello and with the name, it actually responds with the name there. And so let's do this. Not that one. Let's go this one here. All right. Let's do this. Okay. This thing is a little bit weird, right? It's a little. Did I do that? Okay. I always get a little when the keystrokes don't respond immediately. It always messes me up. Let's see here. Sudo Vertx run main. I think I can do it this way. I have to remember if I'm in the right directory. Sometimes it doesn't like it if you're in the wrong directory. Then let's go here. And so web.burr.red, hello, and there you go. So hello, I guess I should put a space there. You guys want to try that? Try that. Pull out your phone and try this, because this is going to get more interesting, trust me. So if you have your phone out, try web.burr.red. I just wrote that little program, or updated that little program, and run it for you. That's how hard it is to build a Vertx application. On the public internet, in this case. So you can SSH in. This is an example of a snowflake, by the way. Right? I didn't do my Ansible playbook and push out these changes. I just simply went in there and edited the code. But there we actually have a nice little application. Okay? You can see right there. And this is a very small server, but there you go. Now, I'm going to actually just kill it real quick. I just shut the server down for those of you who are connected to it. And actually, I do have some challenges with the server now that it does not want to release in some cases. So let's see here. We'll SSH in here. And actually, let me go and bring these guys up while we're at it. I'm just making other connections to it. Let's see. Dun, 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 dun. Let's see. Is it still running? Nope. It actually shut down. Yeah, it shut down. Okay. So that's an example of a web app. But let's do this. Whoop. All right. Let's go here. I'm going to show you this guy now. So the same kind of web application that you saw earlier. But we're going to do it this way. We're going to run a web application that has the event bus built into it. And now, once it gets connected, it looks like if you guys come up here and just put web.burr.red and hit refresh, here's what that's going to look like. Okay? I'm connected, and the server is going to just push me messages. So this is an example where the event bus can bridge across the backplane of the JVMs on the server side and send, and wow, you guys really, all those socket connections, those are all you guys, all right? So that's you guys connecting. So you guys are connecting, and you're getting a stream of messages from my really slow Northern Virginia server, because that's where I was when I set this up. So if it's not performing very well, it's got to come across the entire globe to get here, those messages. But watch what happens when I do these other things. Okay, so we've got messages flowing. And 06, let's show you this. Let's slide up the Java publisher. So now we're going to get Java messages coming in there. 06. Well, it helps if you actually type in 06. And let's actually do this. Let's do a JavaScript consumer. All right, so we're putting all the other guys. So you get Java messages now, right? Okay. Okay, so I can even come in here and say, we have all this stuff happening now. So all this running on the server. I want a Groovy consumer. How about that? I want my Groovy guy running. And so basically on the server side, I have listeners on the server side and all the listeners in this room seeing these messages. And I can come over here and SSH web web.burr.red. And, oh man, 9 minutes. We got to go faster. Come on, connecting. Ding. Okay, we can now say, let's add Ruby messages to that mix. So here come the Ruby messages. And actually, while we're doing that, I'm going to shut down the Java messages. We'll kill the Java messages there. So you're going to lose Java messages, and you're going to gain Ruby messages as soon as that guy gets, there we go. There's our Ruby messages flowing. So all this takes almost no lines of code, right? I can show you the code real quickly. It's super simple, and all this is available on GitHub. So here's my MQTT one. This one right here specifically is like, here's my publisher for Java, right? Here's my consumer for Java. If you actually look at the consumer for others, like here's my consumer for Ruby, my publisher for Ruby, they're almost the same APIs because they all have the event bus available to them. We even have the event bus available as an NPM, so you can just, if you have a pure Node.js application, you can light it up on the event bus too. And so it's a pretty simple tool, but it gives you some amazing powers. Okay, so let me shut these guys down. Okay, we're shutting these guys down. Dun, dun, dun. And it does take a little while to clean those JVMs up. Let's see here. See, we got a bunch of them running. So let's just kill -9 a few of these guys. Okay. It might help if I sudo. We're getting rid of some of them. And oh wait. All right, sudo kill -9. Go away. What else do we have running? And one more. Yeah. It's a tiny little server, so it struggles with all these things. Okay, there we go. Oh, 4006, what it was. And it would help with this thing. Okay, he'd already stopped. All right, so good. We're back to clean again. So let's do this. We're going to go back here. And now let me bring up another server. This is where a fat jar is created. You saw me do a fat jar earlier, but now I'm going to do another fat jar. In this case, I'm going to run this one. It's going to bring up my web server again. If you go to refresh at web.burr.red, okay, someone's already connected. I see this socket connected there. Let me connect. Okay, watch what happens now. A lot of people are connecting. Fantastic. And I'm going to bring up the dashboard. This is an example where the event bus allows you to paint pictures. So look at that, already painting pictures. So basically, if I come over here and I can put it in my B, and you can see what's happening. Now, this is working off your 3G connection, your 4G connection to my server in Virginia, all the way back here to my browser here on stage, running through my phone. Think about that for a second. That's actually pretty amazing. It's going across the globe and back again based on I basically have programmed it so the end of stroke, right, when you release your fingertip, it sends the entire serialized HTML5 canvas over the wire, because I didn't know how to code this, so I'll just send the whole damn canvas that's serializable through the event bus and back out to the actual browser in a thumbnail form. So you guys are having a good time here. And I have to admit, though, in Latin America, I get some pretty awesome art. You guys will have to work a little harder here. But you can also, if you also refresh, if you have refresh, you'll get another panel. I set it up that way on purpose, so I can come over here and you can see my B. Okay, so there you go. So that example is, again, the event bus allows you to do some pretty interesting things. So let's make this a little bit more interesting now. Okay, I'm going to go ahead and just shut that guy down. And I want you to switch to a different URL this time, because this one actually did require a little bit of work. You're going to go to game.burr.red, G-A-M-E, burr.red. And actually, let's do this, game.burr.red. Okay? You're going to get a user interface that looks like this. It says play game, but it's game.burr.red. It'll redirect you accordingly. Okay? Game.burr.red, and watch what happens here. We have a little game we're going to play with you guys. And it's going to involve balloon popping. It's like Fruit Ninja. Well, you guys get the popping balloons there, and I'm going to bring up some other stuff here. All right? I'm going to game.burr.red. I'm going to bring up the leaderboard. Let's see how many of you guys are. Wow, a lot of you guys are already well into this thing already. You guys are scoring points like crazy. There you go. Again, the same kind of concept. You guys are playing on your 3G. Across, in this case, I did move this server to Singapore. The latency was noticeable enough that I did move this server. But we're almost to 1,000 transactions in the few seconds it took me to load these pages, based on you guys' phones, okay? So pops are transactions. Now, the important thing here, you guys keep playing, is you got to understand, this is going to go from your phone, based on each pop is a transaction, to my server, my Vertx server, who is asynchronously then interacting with a traditional Java EE application on a traditional Java EE app server known as JBoss, running the business rules engine known as Drools, who's calculating your achievements and updating the whole system and updating this dashboard in real time. So you can see people have already broken the 10-point barrier. They've not hit the 300-point or 500-point barrier, probably because the game's too hard. Let's make this a little bit easier. Let's come over here. And actually, let's make these balloons big. And go. Okay? Now we're going to some big balloons. You got big balloons? And actually, let's make it even easier. Let's give you red balloons count as 10. How about that? And I want to change the background to blue. And go. Now you guys are having some more fun. You get even more points happening there in real time. You guys think that's cool so far? But wait, okay, you guys are having too much fun here. So hold on a second. Okay, I needed your attention for a minute. Okay? So, this is important. This what you're doing, I know you guys are playing, you're like, oh, this is awesome, I'm playing games. One more time, this is what we're dealing with here. Okay? Your phone is popping these balloons. It's hitting a Vertx game server running on a simple EC2 instance. There's 3 JVMs running on a single server. And we basically have the Vertx achievement server, which holds the body of achievements. We have the Vertx game server, which is based on Groovy. It's dealing with all your socket connections, all your real-time interactions. You'll notice, too, on your phone, you're getting real-time updates to the phone. It's saying, you've got this achievement. You got this achievement. Each achievement is being scored through a traditional Java EE application, again, asynchronously. So you will see it be a little behind because it's asynchronously handing it off to this other process, and it in turn is then letting everybody know. The dashboards know the current achievements as well as your phone. That's the architecture we're dealing with here. Now, you guys want to play some more? All right, let's do this. Let's go back. Boom. All right, we're playing again, but let's make it a little more interesting. Let's make them fast and invisible and, you know, that kind of thing, and go. All right, let's see what it looks like. I lost my little window here. Where we go? There we go. There they are. You're thinking, now the game's too hard. Okay, too hard. But actually, okay, we'll make them bigger again, a little slower. You know, make it a little easier. We'll give you more points for these guys. Dun, dun, dun. And actually, let's turn on the golden snitch. The team who built this with me thought this was funny, so let's go ahead and add that into play. So we change the background color. And now you should have a very interesting extra bonus point there. Seriously, they were like, Burr, let's add this in. I'm like, okay. And now you can see our points. There we go. You can see everybody's scoring. This is the name on your phone. So you guys have these names. Okay? We assign names on purpose because people would otherwise put bad names into the system. You saw what happened when we let you finger paint earlier, right? Okay. This is part of the problem, but it is time for this game to be over. Okay. Let's see. Oh, did it work? And here's what. Here's what's funny. You see there's 2 people still in the game. I've had this problem, especially in low latency environments. The message doesn't make it all the way back to your phone to tell the phone to turn off. So they will end up winning this game because they were able to stay in. It's actually a part, I got to fix this on the server side, so instead of worrying about only the client side. But by default, think about this. We're doing everything between the client and server and making the phone the gaming engine. It's a 60 frame per second gaming engine running inside your browser. And we're simply doing all the interactions here on the server side. If you see your name up here, we actually do have a special prize for you guys. We actually have one of the custom t-shirts I talked about earlier. This nice young lady is going to be passing them out. But thank you so much for your time today. We're at the top of the hour. If you have questions, I'll be available for the rest of the day until my next demonstration where we show you all the cool microservice blue-green deployment canary stuff that we'll show you. All right? Is that cool? If you want these slides, one thing just to make note of here, the slide deck and all the demos are listed at bit.ly reactive MSA right there. That's the URL you'll want to check out. Also follow me on Twitter. I'll tweet these things out too. But thank you so much for your time. Hopefully you had a good time and found this to be interesting. And I'll bring up the leaderboard one more time. So if you're on here, really, we got a t-shirt for you. Come up and get it.